This is the story of Eratosthenes, who first calculated the circumference of the Earth more than 1700 years before Columbus crossed the Atlantic. Eratosthenes was a Greek scholar born in 276 BCE who worked as the chief librarian at the Great Library in Alexandria, Egypt. He studied many subjects and was a well-known mathematician, scientist, and geographer. One day Eratosthenes heard that every year at noon on the summer solstice, the sun shone directly down to the bottom of a deep well at the city of Syene. This meant that the sun was casting no shadows at all at that time in Syene. However, Eratosthenes knew that at noon on the same day, the sun did cast shadows in Alexandria. This made Eratosthenes very curious as to what would cause different-sized shadows in different places at the exact same time. Ancient mathematicians already knew that the Earth was round. They had observed how ships slowly dropped out of sight as they sailed away, so the sail was the last part visible on the horizon. If the Earth had been flat, the whole ship would have stayed visible as it sailed away. The only thing that explained the illusion of dropping into the horizon is if the ocean was gently curved, like a sphere. Eratosthenes realized that this curvature of the Earth could explain the different-sized shadows. When the sun is shining directly down the well at Syene, it means that the sun rays are hitting the Earth at that point at a 90-degree angle. Since the Earth is round, those same sun rays hit other parts of the Earth at different angles. Using this knowledge, Eratosthenes created a method of calculating the circumference of the Earth. The first piece of information that Eratosthenes needed for his calculations was the distance from Alexandria to Syene. Many Egyptians had surveyed the distance before, but in order to be as accurate as possible, Eratosthenes wanted to double-check the recorded number. So he investigated how long it took a camel to travel between Syene and Alexandria, and used that time along with the average speed of a camel to confirm that it was about 492 miles between the two cities. Next, Eratosthenes needed to measure the angle at which sun rays hit Alexandria at the same moment they were shining directly down the well at Syene. So on the summer solstice, he waited by a tall pillar in Alexandria until exactly noon, and when the sun reached its apex, he measured the length of its shadow. Then Eratosthenes was able to use a simple trigonometric formula to determine that the rays were hitting the pillar at a 7.2-degree angle. Eratosthenes now had all the data he needed to calculate the circumference of the Earth. 7.2 degrees is about 1/50th of the full 360 degrees in a circle, so he knew that 50 times the distance between Alexandria and Syene would give him the Earth's circumference. 50 times the 492 miles gave Eratosthenes 24.6 thousand miles. The actual distance is 24.9 thousand miles, so Eratosthenes got remarkably close without needing any of the technology that we use today. And that is the story of how, with a little curiosity and some simple problem-solving skills, Eratosthenes was able to measure the circumference of the Earth 2,200 years ago without ever leaving Alexandria.